Continuing from previous lesson regarding solution of quadratic equations by completing square method, we will do one more question in which coefficient of x square is not equal to 1. Let's get started with the question. The given equation is 4z square minus z minus 1 by 2 equal to 0. Let us call this as equation 1. Remember, if this equation was not in standard form, mean if the first term is something other than z square, second term doesn't involve z, or the third term doesn't involve the constant, then we should first of all bring this equation in order so that the first term has z square, second has z, and third term has the constant. Now we compare it with the standard form of the quadratic equation. Comparing with standard form of quadratic equation. And what is the quadratic equation in standard form? That is az square plus bz plus c equal to 0. Let us call this as equation number 2. Here, by comparing coefficients of z square, we can see that a is equal to 4. So comparison gives us, by comparing coefficients, what we get here is a is equal to 4, because coefficient of z square in standard form is equal to a, and coefficient of z square in the given equation is 4. Therefore, a is equal to 4. Similarly, coefficients of z can be compared, which will give us value of b, and that is equal to minus 1. And similarly, c is equal to minus 1 over 2. This is our first step in the solution of quadratic equations by completing square method to find out values for a, b, and c. For step 2, now we decide if value of a is not equal to 1, we divide the entire equation by a. So step 2 is if a is not equal to 1, which is clearly the case in this equation because a is equal to 4. We divide the entire equation by a, means 4. Divide the given equation by a, by 4, because that's the value of a. So this is what we'll do, and we will have 4z square minus z minus 1 by 2 equal to 0, and we are going to divide the entire equation by 4. This will give us 4z square over 4 minus z over 4 and minus 1 by 2 and divided by 4. So this is 1 by 4. This is division. Okay, this is what we do, and what we get from this division is z square minus 1 by 4 z and minus 1 by 8 equal to 0. And we can either do this way, we divide 4 first and then move the constant term on the other side, or we should have moved the constant term on the right hand side and then divided by a, means 4. Whatever way, we end up at the same equation. Now we are going to separate that constant term. So this will give us z square minus 1 by 4 z equal to 1 by 8. So this was our step number 2. And now what we are going to do for step 3 is that we already know what is value of b, but now we are going to recalculate here the coefficient of z, recalculate the value of a, b and c, or at least we should find out what is the value of coefficient of z. Here a is equal to 1 now, and b in new case is equal to minus 1 by 4. And c of course has been taken on the other side, but c was minus 1 by 8. And now what we do is we find the value of 1 by 2 b whole square. This is what we do. And if we substitute just the value of b, which is minus 1 by 4, and then take the square, we can see this will become minus 1 by 8 and then whole square. And we always add this on both sides of the given equation. Adding minus 1 by 8 whole square on both sides of the given equation now. And what we do is z square minus 1 by 4 z, and the way this equation was before is 1 over 8, and now we are going to add plus minus 1 by 8 whole square on this side as well as on the other side, minus 1 by 8 whole square. And like we know from the previous question that the two terms with perfect square, this z and minus 1 by 8, if we just write both of them minus 1 by 8 whole square, this left hand side is a perfect square of z, the first term, and the second square term, which is minus 1 by 8. Remember, always include the sign, is equal to 1 by 8, and if we take it out of square, this will be 1 over 64. So this is z minus 1 by 8 whole square equal to, this is, if we take LCM 64, here it will be 8 plus 1, this is so, and we get z minus 1 by 8 whole square is equal to 9 over 64. So here again we do the inverse operation. Originally we started from the unknown z, then we did the operation on this and we converted first it into z minus 1 over 8, and then we did the operation on this and we converted this into z minus 1 by 8 whole square. So here what we did, we subtracted 1 by 8. The inverse operation of course is, if we were to do this operation, we will be adding 1 by 8. So that is not hard. But here we did the square, and the inverse operation of operation of square is square root. So we will take square root of the equivalent value of z minus 1 by 8, which is 9 over 64. But we don't know if we take inverse operation on of square on 9 over 64, which is a square root. We don't know if z minus 8 was originally plus 3 by 8, was it 3 over 8, or was it minus 3 over 8? Because both of these could be the possible values upon which we operated the square. Because 3 by 8 can give 9 by 64, and minus 3 by 8 if taken square can give 9 over 64. That's why we can write now z minus 1 by 8. We don't know if it was plus 3 by 8 or it was minus 3 by 8. So we include both of the possibilities, and then we convert this into two linear equations, separately writing z minus 1 by 8 equal to 3 by 8, or we can say that z minus 1 by 8 is equal to minus 3 by 8. From this we can isolate z and get the value for z. Z is equal to plus 1 by 8 on the other side, plus 3 by 8, or here z is equal to 1 by 8 on the other side and minus 3 by 8, and here we can take LCM 8, 1 plus 3, or z equal to, we can take LCM here again, 1 minus 3 here. So this will give us 4 over 8 on this side, or z will give us minus 2 over 8 on this value of z. So that's how we get two values of z, and if z is equal to 4 by 8, the equivalent fraction is 1 over 2 here, or here the equivalent fraction is minus 1 by